So welcome to We Speak Your Language. This is a great episode, at least to me, because when we started this project, one of the things I envisioned as being one of the most exciting things we could do would be to have a fantastic conversation about languages, programming languages, compilers, all the things we've been talking about together with Jan, who is my co-host on this podcast, and even more so enlightened by the experience of having interviewed a dozen people in this space, having totally different experiences. So Jan, welcome home.
Thank you very much. It's indeed great to be here with you. And so we're going to talk about programming languages, I guess.
When did you decide to become a language engineer, a compiler writer, a language guy?
It was in 91. I was a student at the University of Geneva, and I thought doing research was a way to avoid the inevitable fate of all Swiss, that is to end up working for a bank.
Are you going to make yourself popular?
And I was in a group doing object-oriented programming, and we met folks from the banking sectors who were using Smalltalk. And I thought, Smalltalk, banks, that sounds so unlikely. And that got me to thinking, well, yeah, there's more than Pascal in the world. That was the language I was taught first. And and that started the path. And then, then I wrote a paper on how to speed up dispatch in Objective-C, and things went on from there. It was, but really, this was mostly to avoid the inevitable. And 30 years later, I'm still ahead of the curve. I'm still not working for a bank. So I call that success. Yeah. What about you?
I'm one of the very first second-generation computer scientists. My father was a computer scientist at a time where it was so unusual. When I went to school and had to fill forms and say what my father's job was, I ran into troubles because people say, computer scientist, there's no such thing, and blah. It was like very complicated. Now it's very mainstream, but back then it was a very unique thing. And you have to, my father, if you ever have the opportunity to meet the guy, he's like super sweet, but he's incredibly smart. He's super good at what he does. And as a computer scientist, he was world class. He wrote the first ever code generator for the first ever COBOL compiler from Honeywell. And he talked about it very casually because he's not the bragging kind of guy. So, by the way, I wrote a code generator for COBOL, and when I got old enough to understand what that was, I said, wow, and how did you do that? And I asked the first question that I had, I said, what language did you use? And he says, well, I used assembler for that. I said, what? It sounds like a crazy thing. So for me, the ultimate macho thing you could do when being a computer scientist was, working on tools that would allow other people to develop. And there was that meta attitude that I really, really loved about it. And it was super theoretical up to the point where I really remember that day. I'm not like you. I won't be able to give a date or a year even. But it was back at the time where books felt very expensive to me, and computer science book even more. And there was that book about, the theory of compilers. I remember it was a very theoretical book with, lambdas and epsilon over the place. It was not the Dragon book. I can't remember what the book was. I don't remember the author. And I look at that, big book. I obviously could not afford it. Just look at the cover, browse through it, and put it back. No way I could afford that book. I said, wow, that seemed like the coolest thing ever. And I guess it still is the coolest thing ever. I haven't been avoiding working for banks the way you did. As a matter of fact, some of my biggest customers are banks, so I have a different kind of relationship, I guess.
Yep. Well, so I always thought of that kind of work as crushing your ability to be creative, whereas. The thing that I enjoy with programming languages is you can define your own world. The language is a set of rules that you make up, and you decide which ones you want, which ones you don't want, and then you build it and you see how it all plays out. And sometimes it works, sometimes it doesn't, but it's really for me it's just as creative as writing a book. My father was a writer and a journalist, and I know he was making up stories, and I think in our world this is as close to as making up stories. We make up this set of abstractions and design them, see how people can enjoy and use them, and how they interact with the machine. And I find that incredibly I find it exciting, and it's a full employment. You're never going to stop, because people will always come up with new needs, new ideas, new things they need to express. So I've stumbled into the field by accident, because I was hired by a professor who's had funding to do that kind of work. And, I've stayed here for 30 years and have been enjoying it, every day.
Yeah. On my side, obviously not the topic of the conversation today, but YAFL is a big part of what brought me to this. And I remember the day, so we had that course on algos where we were being taught, if my memory serves, algo 68, Simula, algo 68, and so Simula 67, algo 68, and Ada as being 3 examples of algos. And I remember that when being taught Ada, I thought it was pretty awful. I still think it's a pretty awful language, I have to say. And I was vocal and a bit annoying. I still am to some degree, I guess. And Raymond, who later become, my master thesis director, my PhD director, become a very good friend since, he kind of lost patience once and said, Darius, you're so smart, why don't you design your own language? Which was a way, to brush me off. I said, well, that's a cool idea. And that's how I did my master thesis on designing my own language, where I could do exactly what I wanted. And it was a sobering experience, a fairly successful one, because I designed that language as a challenge, and then we ended up, implementing it and then bootstrapping it. And 30 plus years down the road, we are still using YAFL today. So, but I first developed YAFL for our own purposes. And there is one tipping point, and I'd like to have your take on this, whether you experienced that, which I remember very vividly. There was a time in the beginning of using YAFL, and it's a moment that I have seen with absolutely every programming language or translator I've been using ever since. There's a tipping point where you end up looking at a bug, and you realize the bug is no longer in the compiler or interpreter, it's in your code. That's the tipping point. When you know that your error has shifted from the infrastructure is good enough, it's no longer an infrastructure, it is, let's say, it's the developer. Even if the developer is myself. Have you experienced that?
So not that exact feeling. So I think my sort of a similar moment was when I saw somebody using, one of the tools we were building. That was a compiler for actually at the time it was real-time Java, and they came and said, oh, your real-time garbage collector doesn't work, blah, blah, blah. And then we realized, no, it was, their, sort of mistake in coding up the algorithm that was causing a memory leak. And, they thought, blah, blah, blah. But, that was also a very fine moment where you realize, oh, there are actual users that are relying on this. Of course, in academia, we tend to build just enough to make sure we can show what we need to show, and then we move on to the next thing, because that's the academia is beholden to the always looking for the new thing. So if if you have a tool and you maintain it, that's not research anymore, and we would not be, that's not our, the incentive system under which we are. So, in some sense, I miss that, the position of, having something that, other people use. We don't get that in my side of the world.
Yeah, it's a sort of satisfaction. It's a constraint. It's not always fun. Sometimes you have to resist because there you use it and say, I want this. And you realize that this is idiotic and would break like virtually every design decision you had in the language. And you have to resist, and sometimes you can't. So it's not always, such a comfortable position to be in. But it's gratifying because at least they're using your stuff.
So you've created your own language, YAFL, which we mentioned in a little while ago, and you created it in, was it 90 some?
Let me see, 1991. I must have been 26 at the time.
Fair to say that the language has been in use for 30 years?
Yeah, absolutely.
And after 30 years, are you still enjoying it, excited by it, or would you want to get something else, to change it? So how do you feel with a long-lived artifact like this one?
It's a different kind of satisfaction. There are a few things that went into the original design that I've been able to change over time, so that part was okay. And there are some decisions that are absolutely abysmal, and I'd love to be able to blame anyone, but it's all on me. And there's no way I can revert those, so I'm stuck with some poor design. And every time I stumble into those, I say, oh, come on, how could I have been so stupid? But, that happens. But on the other hand, over time, the language we use today is fairly different from what it was 30 years ago. We've been able to introduce quantifiers. We've been able to introduce interfaces. As soon as I learned, someone explained me how Java did it, how it could be done efficiently, because I really hadn't a clue. So where we get there, that's how we started expanding the language. We expanded the compiler as well. One of my very best friends did his master thesis on the YAFL global optimizer, which is still in use today. And then we replaced the code generation scheme. So it is maintained up to date. And of course, I love it because this language is designed by me for me. It is the language where the level of abstraction is exactly what I feel comfortable with. And I'm very grateful to my colleagues who put up with my quirks, because at the end of the day, I guess that's it. These are just my quirks.
I can see for myself that there were things I was fine with 20 years ago, and now that I find annoying. For instance, I started doing a lot of Java in the 2000s, and now I look at it and say, this language is way too verbose, too much syntactic noise, remove those semicolons, fewer braces, stuff like that. You don't have that feeling?
Sometimes, yes. For professional reasons, a significant part of the runtime components we build around our compilers are written in C#, where we can take advantage of lambdas and more functional programming capabilities. Mm-hmm. And it's not how I was educated, so it's been a slow percolation. But now from time to time I say, oh, some of these things are really, really cool. Some of these things I have a number of objections to this programming style, but I think it's really amazing. And I looked into it. I wouldn't say putting it into YAFL would be impossible, but it would be a gigantic amount of work, and I'm not sure it would be worth it right now. Because something that comes with experience, I have to say, is that at the end of the day, as exciting as we find it, it doesn't matter as much as we think it does. It really does not. It's not as groundbreaking. It's fun. We can write nice one-liners, but in the grand scheme of things, it's not as if we are like 50 times more productive, or even twice more productive than we were using, say, Pascal, for instance. It's nowhere close to that. At the end of the day, it doesn't matter that much. It's more about our intellectual fulfillment.
Yeah.
Oh, so I think, you may